Hi, and welcome to another video. In this video, we're going to be tackling a problem with binary trees. Even though binary trees might be something you don't know, I'm going to be explaining what binary trees are in this video. First, let's take a look at the problem. Given a root node of a binary search tree, return the sum of values of all nodes within the values R and L inclusive. The binary search tree is guaranteed to have unique values. So, for example, if this is the binary tree and we want to find the sum of values from 7 to 15, then the answer would be 32. And here's another example from 6 to 10, the output is 23. First, let's take a look at what binary trees even are. What are binary trees? Binary trees are a way to store information in nodes in a tree-like format. So as you can see over here in this diagram, we have these nodes, which are the numbers, and they are connected together in a tree-like format. As you notice, each node is connected to one node. As you can see here, it's only connected to 13. Two nodes, as you can see, one is connected to both 2 and 3, or it can be connected to 0 nodes, as you can see on these bottom numbers. Nodes that aren't connected to other nodes are actually connected to the null value, which signifies that there's no other value attached to it. So here you can see in the 6, the second value is going to be null. And additionally on the bottom, the other values are null. What are some properties of the binary tree? So if we're given a node, we're going to call that node root. We know root.val, which is the actual value that's stored in that node. You can know the root.left, which is the node left value, and the node's left value is for 4 is 8 because it's attached to 8 on the left side. And then we also have root.right. So here for 4, the right value is 9. And with these three properties, you can navigate throughout the tree. And remember, if I have something like 6, which doesn't have a left value, that root.left is going to be null. So let's see whether we can solve this problem that we looked at on this notepad. So to do this, we're going to be using a recursive system. And this recursion method is going to be able to navigate throughout the entire tree. Because we want this method to return an output, I'm just going to have another method do the recursion for us. And then I'll have this actually be the actual method that's going to return the value. In order to have the sum that we calculate in the recursive method accessible by this method, we could have it as a parameter, but we can also have it as a class variable. So I'm just going to have int sum equals 0. And obviously for protection, you can do private int so that outside classes cannot access your variable. Inside this method, I'm going to call my helper method. So I'm just going to be calling it helper, and I'm going to input the 3 values, and then I'm going to return sum. If you are to make this multiple times, it is safer to actually initialize sum over here like this. Now I'm going to be creating that helper method. And to do this, I'm going to do private void helper. And we have the exact same 3 parameters as we had over here. So now we've set up our recursive method. So what we're going to do is that we're going to continuously call this and add the value to sum if it meets the requirements. The first thing we need to do is see whether the root.val is in between L and R. So if root.val is greater than equal to r, and root.val is less than equal to r, then what we're going to do is that we're going to have sum, which is that variable, plus equals root.val. So remember that root.val is the value stored at this node. Then, to make it recursive, we need to recall the function. But you can't recall the function if the value is null. So what we're going to do is that we're going to call the helper method on root.left, which is that left node, and root.right, if those values aren't null. So that means if root.left not equal to null, we're going to call helper of root.left, left and right. And then also if root.right is not equal to null, we're going to go ahead and call it on the root.right as well. Remember that in the Java shortcut you don't need these brackets if there's only one line underneath, but it's always nice to have it just in case if you want to add more lines later. But I'm just going to remove it just to make our code look a little bit more cleaner. If you want to run your code, I just took a couple lines to make a binary tree, but you also need that tree node class inside that same file location. So if you would like to create that tree node file in order for you to test your code, then go ahead and pause the video, copy over this code, and do that yourself. Great. Now, let's see whether we can run our program. So as you see, I took the first example and created a binary tree with this value. And as you notice, the output is 32, exactly like we have in example 1. So that is the program in order to solve this problem. I hope that with this video you learned what binary trees are and you're able to use this basic concept in your code in the future. See you soon!